Let's build a Nutcracker. This design consists of a top-level assembly with a couple weldments and a handful of parts. Part, weldment, and assembly details like geometry and hole type and hole location are detailed in drawings that are available for download, linked in the description below. So why a Nutcracker? Where I live, there are hazelnuts everywhere, and there are acorns everywhere, and millions of calories drop to the ground every year. I want more people with the knowledge to harvest and process their own food. And I want early engineers to understand that new technologies do not have to be limited to batteries, to Silicon Valley, to automation. New, helpful, innovative technologies can be made with scrap materials in your garage for your neighbors. The materials that I'm using consist of a couple feet of 1-inch square tubing with 1/20 thou wall thickness, a foot of 1/8 inch by 3/4 inch flat bar, all steel, 2 1/4 inch shoulder bolts that are 1 3/8 inch long. A 1/4 inch shoulder bolt has 10/24 thread per standard. 4 1/4 inch shoulder bolts that are 3/8 inch long, and these will also have the 10/24 thread. We need 2 3/8 inch bronze sleeve bearings that are 1 1/4 inch long. The inner diameter is 1/4 inch. And then we need 4 of these that are 3/8 inch long. And so these are the bearings that the shoulder bolts will ride in. We want 6 nylock 10/24 nuts to cap the shoulder bolts. 12 bronze washers designed for a 1/4 inch clearance hole. This is for bearing the lateral loads on the mechanism. We'll need a couple weld nuts that have their threads drilled out to 3/8 inch, and a die spring. This die spring will go into those weld nuts. So for the die spring, we want a 3/8 inch outer diameter, 1 1/4 inch long. I'm using a Raymond blue spring, which has a stiffness of about 50 pounds per inch. And finally, a set of vise jaws. I'm using a set for a Wilton model WS4. The tools I'm using, besides tools for drilling and cutting, are an 1/8 inch Allen wrench, a 3/8 inch hex wrench, a 3/8 bit to drill holes for the bronze bushings and die spring, and a 10/24 tap with number 25 or 5/32 inch pilot bit. All right, to get started, let's go to our metal fabricator, Trevor, who says step number 1 is to
wipe the material with a acetone rag to get all the oil off of it. That way I don't have to deal with oily material for the rest of the project. The next step after that is cutting all the pieces to length.
In your own garage, you can cut pieces to length with a cutoff disc, a hacksaw, or a bandsaw. Here I'm chopping that 1-inch square tubing. It's important to design around standard material sizes in order to minimize machining operations. That means it will cost less to make. I use a steel vendor's catalog to spec size, and I chose the 1/20 thou thickness because that's thick enough to tap for sufficient thread engagement. And the next step,
after cutting them, drilling all the holes,
I like to punch the location so the tip of the bit doesn't wander. In your garage, you can use a power drill or a hand crank manual drill, a drill press, or a mill. And after drilling, it's time to tap. Trevor reminds us that when you're tapping a hole,
one important thing is to make sure the tap is lined up properly, and the easiest way to make sure that happens is drill your hole and then use the drill, like if it's fixtured in a milling machine or a drill press, then use the drill as a guide to locate at the top of the tap so you know that you're tapping straight into the hole as opposed to at an angle. And I have recently discovered the joy of machine tapping, which is so much easier than hand tapping, because hand tapping, you're turning it a little bit at a time, and so it's a interrupted cut. And then fixturing, welding, here we go. And then assembly.
So the parts are made per the drawings, and we have our fasteners and hardware. Now we can just put it together just how it's shown in the drawing. The bronze bushings and washers are not absolutely necessary, but they help with quiet, smooth movement. If you just have steel on steel and you don't oil it, then it could squeak on you, or it could gall. And galling is when two similar materials rub against each other and start tearing each other apart. To avoid galling, you want one of the materials to be softer than the other. Once everything fits up nicely and you confirm that the travel functions as you'd like it to, then you can go through and torque everything down. I'm throwing in a couple steel washers between the linkage arms just to space them out. And that's it. Nice work.